I thought I'll take this opportunity to summarize the whole chapter sequence and series again. Okay. Now, like I said, sequence and series, what's important for you to know is the sequence, as the word itself tells you, right? It is an order. There is a certain order. So when it comes to number, if you see certain order, whether it's increasing or decreasing, that is known as sequence. And when you see that certain set of numbers, if it increases or decreases, it follows operation. So operations like either a certain order of addition or subtraction, or there is increase or decrease due to multiplication or division. So these are the two things happening with that set of numbers, a group of numbers, right? Now, so for example, if I bring a set of number, like for example, example number 1. Let's say I start a number with 1. Next one I want to write it as 3, and next one would be 5. Now, do you see some pattern hidden here? Yes or no? Can you guess my next number? So I have 1, then I have 3, 5. What would be my next number? 7. Okay, then 9. Okay, so you got it right. So here, which one do you think is happening?
Addition.
Oh, addition. So you see that 1 plus 2 is giving me 3. 3 plus 2 is giving me 5. So which means the same number. So there is this pattern here, and this is this order, a law. So which means here the law or the order or the rule followed is there is an increase of 2 with every next number, right? So that's why this is known as sequence. And since the operation is used as increasing, right, we see that there is this common difference. So what is common here? The rule I can find it by, common difference. So my common difference, so term 2 minus term 1. So, or I can have it as, let's say term 2 minus term 1, which is term 1, term 2. So term 2 is 3. 3 minus 1 equals to 2. Now, is this enough? No, like I said, it has to be a rule and followed by all. So just want to be sure. Okay, so let's verify further. So I want to take 1, 2, 3, 4, 5. Okay, let's take term 5. Okay, so I am taking term 5 minus, want to find the difference, so I'll take term 4. So term 4, so which means 9 minus 7, and it is still 2. So now I'm confirmed that the rule followed here is a common difference. So this is the common difference, and in short we can write it as what?
D.
Yes, as D. Difference, no? D. So that's the rule here, D. And this is specifically known as arithmetic progression, and in short we call it as AP. Correct? Yes or no? Now this is the definition, the overall view of arithmetic progression. Now I told you that the increase and decrease may not be always with plus and minus. We can also have increase times and divide. For example, if I have, let's say 2 and 4, 6, 8. Can you guess the next number? 10. 10. Then? Now you see that everyone is able to give me the same answer because you identified the rule. Now what is the rule? Is it the difference? Now let's check. 4 minus 2 is 2. 6 minus 4 is 2. 8 minus 6 is 2. So we can identify this as what? Arithmetic progression, right? Now what about this? If I have this rule, can you guess the next number? Yes? What would be the next number? Did you identify the rule here? I got 3 as my first term, 9 as my second term, 27 as my third term. What would be my fourth term? 81. How did you get this 81? Yes, so you found out that now there is this certain pattern or rule followed, but this time the rule is not the difference, because I checked 9 minus 3 is giving me what? 6. But is it the same when I subtract 27 and then 9? No, it's different, right? So even though there is this pattern, now your pattern is not because of plus and minus. Now it comes to the times. So you notice that when I multiply with the first term times 3, I am getting 9. And I am reassuring whether it's true if I do the same. So 9 times 3, I am getting 27. 27 times 3, I am getting 81. So now I found out that there is this certain increase. And this is caused by multiplying 3 with every term. Right? Yes or no? So this is known as geometric progression, where the increase is due to times. And how do I confirm? So here you can confirm by, so like I said in the previous one, you had the difference. Okay, to find the rule, we found out the difference between the terms. Now to find out the rule here, what are you going to do? So instead of, so how would I get this 3? If I didn't know 3, how would I get using this 2? Any guess? So let's say I did not know that it was 3. So how would you find combining these two? What would you do? What operation would you do? Oh, divide would work here, right? So we have to take term 2, that is 9. So this is term 2, divided by, take term 1. So term 1, which is 3, I am getting my value as 3. So basically, I am trying to find the ratio, right? So trying to find the ratio between the terms. So let's take term 4 and divide it by term 3. So my term 4 is 81. When I divide by 27, I am getting my ratio, that is 3. So you see this 3 is appearing again and again. So which means it's a confirm that the rule is 3. And this is my common ratio. Because it's common, coming again and again, that's why we call it common. Now because we are doing division, it's known as ratio. So, and symbolized by R. Are you getting my point? So this is just these two things in sequence that you need to know: arithmetic progression and geometric progression, right? And the rule out here followed is difference. Because of this rule, okay, the difference is all same. That's why I'm able to say that it is arithmetic progression. Here GP, geometric progression, the ratio is all same. That's why I'm able to continue my sequence. So did you get the point here?
Yes.
Okay. Now let's try to solve some examples.